is just a little quick video to talk about something inherent within the seed um, that hopefully will lead into another video that's a little bit more ambitious. But just to set the table, I have a seed here, um, standard as you'd expect. The only thing that I've done additional to the normal process is have created a vertical axis on it and marked the points that allows for me to draw this section of a square. So you've got, I've given you the top part of the square and the side part, because really I'm just going to focus in on this quadrant. I've also marked the radius of the circle in two directions. That'll become evident why as we go through this little exercise. But I noticed something. I was just kind of hunting the reasons why one of my methods for getting the 5 was working. And I didn't get to a satisfactory answer, but I did notice this, and I thought it was kind of neat. If you mark a straight line, so I mean this is our radius. Now we're looking to look at right angle triangles, just to give you an idea of where I'm going with this. You've got your radius r. All right. Now we look at where the point of the seed is contacted on the surface or on the circumference of the circle. Okay, and we'll just draw a straight line to the origin or to the center of our circle here. All right, and you'll notice that this gives us the opportunity for a right angle triangle. Okay, so I'll draw that in. Because it's on this point, we know that it goes straight down to this point. So I'll just mark where that falls on our radius. Okay, and as expected, it falls at the halfway point. All right, now I'm going to do the same thing for this point, just because. I mean, we have the point, we know it's there, so let's see what that line gives us as far as a right angle triangle is concerned. Okay, there it is, and I'll do the same thing here. I'll just draw it straight across as I did for the other axis. Now, if you look at this, and when I say this, I mean specifically this now, the way this quadrant is divided up. I'm going to draw over my pencil here just to make it stand out a little better. We have a square. In the top portion of this circle. And you should notice that these sections of square are related by phi. This square is in phi relationship to this square. And the line segment of the radius is divided between this, it's halfway of the circle, but at the edge of the square, it is also in phi relation. So the width of the rectangles are in phi relation to the squares, and the two squares are in phi relation to each other. I thought that was kind of fascinating. And it speaks to something on the notion of fractals, because if you square all of these circles at the same time, you see this relationship show up there as well, which is the ambitious project I'm going to try and do for another video. But yeah, I just wanted to highlight that inherent within the angles of this circle, where the touch points are, phi is already there. I think that's what makes the seed as special as it is. And there's a lot to be taken out of this. I wouldn't even be shocked to find out that these triangles are in phi relation to each other because the squares are. I think that's an iron rule of geometry, if I remember my high school. Also, just because I think it's cute, say it. It's probably meaningless, but I also like that this is in here too. Because that's the way I roll. I do like the star. Let's do some definition. It's completely out of proportion. But I like that it's in there. All right, that's it for this one. Just wanted to kind of set out some teasers as far as what I'm going to try and do next. And we'll see if I can do it in a way that makes the video interesting and not tedious, because it is a lot of work to do what I'm thinking about doing. I might just do a couple of the circles and let the relationship show itself in one spot as opposed to across the entire seed. All right, we'll talk to you later.